Here's an example of making a scatter plot, and this time not with nice, easy numbers to work with, but ones that will cause a decimal slope and a few other things like that. And so, make a scatter plot with the information from this table. And the scenario making up is a book is published, and these are the number of days after it was published, and these are the number of copies that were sold on those days. Let's see if there's a trend to that, if there's some kind of systematic thing happening. And let's analyze the data. And this is called analyzing it. We'll see what happens. You need to make the scatter plot, draw a line of best fit, what makes sense, looking at it visually, write the slope-intercept form of the equation, and then I'll give you an equation to determine. In fact, I think what I'll say is how many copies were sold approximately on the 30th day. That's not one of the days up there, so we'll use this to make a good estimate as to how many were on that day. And then there's a graph here. So if you have this paper from the Dropbox, you would be able to do this or just write it out yourself. So you try to do it and then come back and watch me go through it, and I'll explain parts of this. Okay, so I'm going to start with coming down here to the graph, and I see that what should be the x's, because the number of copies really depends upon how many days it's been since it's been published. So this part, the one of the bottom ones are dependent on the number of days. So these are the independent ones. You're going to march along in time regardless of what happens with copies. So here, I see they're all out of order. Doesn't matter, perfectly fine they're out of order. I'm just going to graph them each, but I see I'm going from 9 to 93. So it looks like I can do x's from like 1 to 100 on the bottom. And on the bottom, my highest number, 610 is my highest number. And my lowest are in the hundreds. So I could go up to say 600. But since I have 10 of these, I think I'll go up to 1,000 and then just let the graph look how it looks. So on the bottom, looks like I can go to 100. I should make these 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And that will cover all of the x's. And on the other side, if I'm going to go up to 1,000, I'll do 100 by hundreds here. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. Yay, I can count really high. Now, let's approximate where those points are. The first one is 9 and 610. So 9 will be just before the 10, and 610 is just above the 600. So if I put a dot here, that clearly is too big for this, but it's going to work because it's in the approximate place. You don't have to be perfectly exact. Hand graphing never is. It can't be. But we can then go, we can still get a good approximation of the trend that would be here in this data. 40 and 492, so 40 is on the line right below 500. 71 and 263, so just past 70, barely, can't even really see on here. And 263, 70, 263, that would be about 250 here, so a little bit more than that, right off the line. And the next one's 20 and 550. 20 and 550. And then it's 87, 180. 87 and 180 would be a little less than the 200. 25 and 480. 25, 480 is going to be a little bit less than 500. 55, 352. 55, 350. Be about halfway, just slightly more. Not really, you can't really tell the difference, so about halfway. 93 and 121. 93 and just over, a little bit higher, over 100. 64 at 310. 64 is almost halfway. 300, just a little over there. Okay, that is A, draw a scatter plot. We have just scattered the numbers based on their x and y coordinates here on this. So back up here, make a scatter plot, just did it. Now let's draw a line of best fit. Now, I like to do these by hand, and as a result, I'm almost always wrong. So let me find some kind of straight edge, such as a ruler, and let me see what would make sense here. So I have a number of ways. It looks like I'm going to have some above and below these. So I can't get a line to go cover all of them at once, but that's the point of scatter plots, is you find a line that matches either most or is close to them. So if I did just the first and last one, I could do that, but I'd have most of them above it and only like one below it. Oh, that's pretty close. I could do this here where it's the next one, the first and last, maybe this one and that one. So you have a number of possibilities on it. I think I'm going to do, let's see, if I do this and this, I don't know, I could do first or second and this one or that one. So I could go up a little higher, maybe the first and the last one. I think what I'm going to choose is this first one and then this one over here. So if I choose this one, okay, I'm going to put a little arrow over it just to remind myself I'm choosing it. This one here. That covers most of them pretty well. You know, somebody could say, well, you know, I would rather that we do this one and this one because it'll make it a little more even. I don't know, maybe the first and the last one. In this case, the first and last one will work too. I'm purposely not choosing the first and last to show you that it's okay not to use the first and last one. Sometimes the last one is in a weird place and you don't want to use it. And I want you to have that idea that you use what makes the most sense to you. So I don't think, I think either of these two and either of these three will still give us the same approximate line. Well, using those two as a, oops, I need to actually draw the line through them. I'm busy thinking about the slope too much here. So if I do, let's see, I'm trying to get right about in the middle of both of them. That would be approximately my line of best fit, I think. Maybe adjust a little bit, but it's close enough. So there's a reasonable line of best fit. And since that would be continuing, I would put that arrow. Since it started up here, I don't know where it went before that. So actually, it probably couldn't have gone past that because the book was published, so there's no 0 days. So I'll just do the arrow going to the end at the y-axis. Now let's come back up to the questions. Draw a line of best fit. Done. Write the slope-intercept form of the equation of the line of best fit. Y equals mx plus b. Now that means we need the slope and we need the y-intercept. The reason why I was picky about picking two of these was because now I can use those 2 points to get the slope. I could do a rise over run, but that's the same thing as doing the slope. Y equals y. Oops, it's not y, it's m. Of course, m equals the second y minus the first y over the second x minus the first x, but we need the 2 points. And so those 2 points are, back up here, I chose this one, and I ended up choosing, what is it here? I ended up choosing, oh, it was the 71. So the other one down here is the one at 71. And so 71 and 200 something is 71 and 263. So I can write them as points like this. If it's easier for me to remember that it's 263 minus 610, 263 minus 610 over 71 minus 9, which gives me negative 347 over 62. Okay. So when you get that and then you divide, let's do it in the calculator. So I do 347 divided by 62. The calculator doing that. You get that number. Now I know it's a negative. There's the negative here, so I'm going to put negative here first. I don't need to use the negative to do this. 5.59677. It says to round to the 10th place. Well, that's nice on this one because here, well, the 9 would make the 5 into a 6. But the 6 makes the 9 into like 10 more anyway, so that definitely has to be a 6. 5.596, that's very close to 5.6. Hence, therefore, since it says 10th place, 5.6 it is. But I'm going to make this approximately, because it is approximate. We now just estimate, we had to just do an approximation sign. Now over here, I can keep the equal sign for now, and I'm going to just use the approximation in my words later. Now we need the y-intercept. On the graph, we can make a really good estimate here, because if that's 610 and it keeps going like this, it looks like it's about 650, 650-ish, about halfway on here. If it keeps going, we're probably hitting 650. So I'm going to guess about 650. And I would be okay to include that. If we did this as the answer, that's clearly a reasonable answer for this one. So that would be a good equation for it. Now, let's see how close we can get, though, how much more meticulously detailed we can get a more precise y-intercept by using the 2 points that we used. And what we can do is, well, let's see, 2 points? Yeah, either, actually one of those 2 points. If we take any one of these points and put it in here, it will give us the b. Put it in this one here. We can put an x and a y. I think I don't want to pick points that are a little bit off, like this one and this one. They would give sort of a skewed one. Let's use points that are either on or really close to the line. And let's use one of the 2 points we used for the slope. That would be the safest thing to do. Well, these are easier numbers, so I'm going to do, if the y is 610, well, actually I'll write it out first, negative 5.6x plus b. And for the y, I'm going to put 610. And for the x, I'm going to put 9. Now I can multiply that. 610 equals, I come up with that before, 50.4. Let's do it here. 5.6 times 9. So I get 50.4. And it's a negative plus b. So this is 610 equals negative 50.4 plus b. Now when I add 50 plus 0.4 to both sides, 660.4. That's pretty close to the estimate I was making there. But now we have a more precise answer. Y equals negative 5.6 x plus 660.4. That would be a better equation to use. I would accept this because it makes sense with the graph. I do want people to be able to do this, but realistically, having the graph, if you can extend the line carefully, it would make sense to estimate that. Now on this one, we can use either of these equations. I'll use my more precise one, of course. Let's put 30 in because the number of days are the x's. So that means 30 can go into there. Y is equal to negative 5.6. So I'm about to write x again instead. Let's put 30 here. Plus 660.4. So 5.6 times 30, 168. So it's negative 168 plus 660.4. And that means I would do 660.4 subtract 168. And I get an answer of 492.4. Y equals 492.4. And I didn't ask you what the Y was. I said, how many copies? So you would say, oh, well, we didn't sell part of a copy that day, so that means we rounded down. This is a case where even if it came up to 0.8 or 0.9, rounding it up wouldn't make sense because it didn't sell a partial copy. It would make more sense to round down, even if you had 0.999 in this case. But here it's an easier rounding because it would automatically go down. So we would say about 492 copies. I'm going to say approximately. 492 copies were sold on the 30th day. 492 copies would be a short answer of it, but this makes a sentence answer there. So let's review what's happened here. started out with some data, put the data on a graph, used that graph and what made sense visually to make a line a fit, as best fit as we could. Used 2 points from that line that were on the line we drew to get a slope and then a y-intercept to make the equation. And then we used the equation with a value for the x in it. So this is also how you can see to do it with decimals. You just round when appropriate and round when appropriate, or not round if not appropriate. Hopefully that helps for seeing how to do one of these types of problems. A good deal of steps to it, but it is a common thing in math to be able to take data, display it in some form, and analyze it in order to use it. So this is a very important concept and technique for what we need to do in math. Thank you.